Welcome to the demo video for Sprint 0 of the DLSS Taco prototype work cycle. In this demo video, we're going to go briefly through our Sprint 0 topics for today, namely an introduction to what the Taco prototype project is, some of the goals of it, mention the members of our team and our roles, and then go through some of the work we did this past week in getting this started. So first, we'll say that DLSS Taco is part of our SDR3 roadmap. SDR3 is the future repository evolutionary plan for replacing our digital repository components. The first part of this being we need to look for a replacement to Fedora 3 and our wrapper code for that, given that Fedora 3 is no longer maintained code. A lot of our repository has a lot of core dependencies on this very internal component, and that makes it an important component that we're starting with in this prototype. The prototype, so the Taco prototype, we are thinking more about this being our SDR3 system, our future system management API and persistence skeleton. Again, it's replacing Fedora 3 and the code that we use to wrap it at a skeletal level. It's really wrapping an API that allows us to deposit resources, which would include binaries and metadata for our digital repository, into our system. This would be used then by clients on top of it that are ultimately user-facing, but we're talking relatively deep in our system stack. For this work cycle, this prototype work cycle on Taco, we have the goals, the functional goals of being able to deposit a resource into that core via an API, being able to retrieve the resources from that core API. This is retrieve and not query. And then we know that that management system will persist those resources in what we've selected to be our canonical data stores for our digital repository system. As a stretch goal, we're hoping to also build a skeletal resource processing framework so that we can have complex workflows assigned to objects that go into this management layer via Taco. Our technological goals for this is that we're hoping to drive forward our emphasis on building systems that have clean boundaries that are represented by APIs between components. We're hoping to test some implementation options for our emerging SDR3 design, which is the outcome of a previous design work cycle, trying to think what SDR3 design at a high level would be. And then as stretch goals, we want to start vetting our core repository data models and metadata profiles. This is not the entirety of our descriptive metadata or otherwise, but just what we need for processing internally by our system, and to test the feasibility of some possible technologies for our repository. As process goals, we're hoping to get something in code to give our SDR3 redesign process something real-er to see, to test our presumptions and be able to iterate on them. This is a part of our agile approach to our work generally, and this work cycle also is meant to give feedback on the design efforts following that agile and iterative approach. And then just as a final note, our goals for this system, for this Taco prototype, are meant to be at a very high and skeletal level. We're trying our best to avoid rabbit holes or any sort of edge cases, just in order to get an end-to-end skeleton of this management component represented by Taco written up. So those are our functional goals. The team for this work cycle, we have tech lead is Erin Collier, and developer also is Justin Coyne. For our DevOps liaison, or our DevOps engineer and ops liaison is Erin Fahy. Our product owners are, we have two, because we're lucky like that. We have Hannah Frost and Ben Albritton. For our management liaison, we have Vivian Wong. And then I am Christina Harlow, and I'm our DataOps engineer. We also have two consultants. Mike Giarlo is consultant on repository development, and Lynn McRae is our architecture consultant, as he is our current repository architect. All right, so if you want to see some of what we're up to, this is the Taco GitHub repo. This is a good place to start for information. The link will be in the YouTube description for the video. You can see a very big taco, but also you can see some of our code and development practices. I would point out this as a great place to keep tabs on what's going on. We also have a wiki that we'll go to in a second for details on some of our selection. As this is a prototype work cycle, we're trying to be very good about keeping documentation on our process and what direction we decide to go. And then fed out of this or served out of this GitHub repo through GitHub pages, we have at this link our Taco API code. And we'll talk a little bit about that in a second. I think that's all we need to say for workspaces. Now we want to go into, as part of Sprint Zero, one of the first things that we had to discuss was to decide what language, what frameworks, what specifications, what deployment practices we wanted to use for this prototype work cycle. I would point to the wiki that I pointed out before for information or documentation on how we made those selections. Thank you, Erin, for writing all of this up. We have decided for at least this prototype, and this has no bearing or effect on expectations of any other code following this. This is just for the prototype. We've decided to go with the language Go for purposes of development. This follows us going through the tech team going through some criteria for why we would want, or what we would want from our prototype and selection. So we wanted something that could work with serverless components, since we are looking at AWS fairly heavily for running this. We wanted something to be statically linked, something that can make statically linked binaries, aka a compiled language. That fed into both concerns of staying away from Java due to performance and our own ability to pick up the language rather quickly, but also fed into our deployment concerns. Again, serverless, AWS, trying to find the best way possible to approach deployment of those products or of our code, and Go seemed to fit both of those. We wanted something with Swagger support. So Swagger is an open API specification that we're using, and we'll see an example of that for a second. But given the focus on APIs, we wanted to use a consistent and community-supported API specification. And Go has a great Go Swagger library that supports both validation and management of our Swagger API specifications, as well as code generation based off of specifications. Yeah, I don't know. At this point, I'll stop and see if the tech team has anything else they want to say about the language selection or any of the criteria brought up so far. All right.
I think you said it well. The only thing I would add is just to extend on the static link binaries fed into a decision to try to keep the container objects as small as possible.
Yes. Cool, thank you. So that's the selection of Go. For Swagger, like I said, that's an open API spec, and it's heavily community supported, perhaps outside of libraries more than inside, but this is why we're using it. For Docker and ECS, I wonder if you want to say a few words about that.
The decision to move towards a statically linked binary is really leveraged by using Docker containers to essentially create just the container itself that would support the binary. So the ability to deploy a container with 0 runtime dependencies is a goal that we're trying to shoot towards, which just lessens the operational concerns down to the smallest amount of concerns that we'd have to carry over time. So it felt like Docker was a very easy choice once we decided on the Go language. Because it's Docker-based and AWS is our deploy environment, that is a very easy connector to the Elastic Container Service that allows us to parallelize the containers, parallelize instances that the containers run on, and gives us a repeatable deployment practice through CI and through the AWS microservices frameworks.
Cool. Thank you, Erin. So that's a review of our selection. I would also mention we did do also some criteria also for the persistence layer. So this is not just what language we're developing in, but also because Taco is replacing Fedora 3 in a lot of ways, and it's at the heart of our repository system. It's where we store our repository objects. Persistence layer criteria and selection were also gone through. We were thinking about performant JSON support, since we'll be using JSON LD for our primary object representation, data representation. You can see a list of criteria. Cloud supported as well. I would mention at this point that we're trying to be cloud first, but also remain cloud neutral, which leads into some of the language selection and deployment selection options, but also for databases, that's a little bit trickier. So we went through our options for what we would like to see for either metadata or binaries. And we ended up deciding to go with DynamoDB in AWS and having that have, for our metadata, and that would have a graceful degradation path to CouchDB in order to support moving back and forth between AWS and not. So trying to fulfill the ability to be cloud neutral. We can't exactly do that here, but we do have a local parallel that we can use. And then for file persistence, at least for the time being, because we still need to gather use cases for our file maintenance and management. But for file persistence, we were just starting with S3. And again, that could just have a migration path or a degradation path to some sort of file system or NFS mount locally if need be. All right, so that's selection. Now we're gonna look a little bit at some of our code and specification work. If you go into our code base, the first thing that I am gonna show is our Swagger spec. So this is, Swagger again is an open API specification. It's used quite heavily by the community outside of libraries, and we decided to go with it. You can see here that it specifies definitions for our RESTful API and routes and links to operations based off of which command and which route. I will scroll down the bottom. It allows us also to define API models, so just object models for what we're passing back and forth. And we're hoping that eventually this will sync up with our overall repository metadata application profile so that we have a shared and consistent understanding of our objects across all components of our system. There's a lot that we have yet to leverage in Swagger, but this has been enough to get us started where we can actually use the Go Swagger code to generate in Go the structure of our API. And so this is all generated code that gets regenerated whenever we push up a new version of our Swagger API. And it just gives us the ability to have this feed into our API endpoint, which we'll see in action in a second, and then link it through the concept of handlers to our specific operations that we need to write outside of that API structure, such as once you receive this JSON object, persist it to DynamoDB. I'll stop for a second and say, do one of the developers want to mention anything else about the structure of the code base or the use of Swagger at this point?
I think you've covered everything very well.
Okay. Justin, I want to make sure you in particular, because you've done all the handlers work. So cool. What you can also see for the API, so from this GitHub repo, Go Swagger also allows us the ability to generate this documentation for our API specification. So this is served through GitHub Pages, and it pulls directly from that specification file that we just looked at, the swagger.json. So whenever that updates on master, this will be serving up to users the current API specification documentation. So it takes that JSON and makes it into something that looks a little bit better. You can get more information about objects that go in and out, what the responses look like, the definitions and operations linked to particular routes. It's just another bonus for using this community specification, and as well as Go Swagger library. All right, so that's Swagger and API. The Go code so far, we did a very simple walkthrough to show the generated code and then the handlers, which also linked to some of our other code in the repository for being able to connect this API to our persistence layers or other AWS components we're still developing. What I would like to show, and hopefully this will work, is how we are able to then build the code. Let me make this a little bit bigger. And you don't need to see the Spark stuff, because that is a different project. Okay, so right now I'm just in my Go code base for that GitHub repo that we just saw. We have built the Go binary, but just to show, I'm building from the command tacod main.go that builds a binary called main in this directory. So there's that Go binary. We're less interested in building that here and more interested in showing how we can build this in a Docker container. So we have our Docker YAML file in the repository and can build a Docker container that basically contains that same binary, that same Go binary ultimately in it. With that built, we can then Docker run, and I'm running just that taco Docker image on port 8080. And it's got within it the binary we just built. So then if I go to this URL just in my web browser, and I know the route's going to be v1 because we are versioning the API and resource, it returns what we expect, which is Git is not allowed on this resource route. What might be more interesting than seeing what we expect, which is an error, is if we do a post. Here, I'm just doing a post with a stupid, simple JSON hash that has our required field so far for an object, which is source ID and title. And the rest of this is just a post to that same route. We know that posting against the resource should create it, or at least stub out being able to handle passing that JSON object off to where it would get persisted. So we do that, and it returns what we wanted, which is a UUID for the object. This will ultimately be replaced to handle Druids, which is our SDR3 specific identifier minting for resources. Returns a quest ID so that we can follow this, what will ultimately be the asynchronous processing of that resource through our workflows. That's that workflow skeleton we talked about as a stretch goal earlier, and the start of a state for what that resource is going to be. Now this needs to be cleaned up, but for a skeleton built in Sprint 0, this is where exactly we want it to be. And all of that is just running on that Docker container that we can then deploy to AWS ECS instance, or service. One final thing that I think we want to show, so that is the deployment practice with this change in selection of framework and specifications and deployment and how we're dealing with AWS. We have set up Circle CI for our continuous integration tool. This is just the Circle CI dashboard for our Taco repository. And all those faileds are not fails. They're just showing the developers working, hard at work and trying out builds. We can see the last build on master, which is this guy. If we go into that, it shows us some information on how it took our code. It ran tests. Well, it spun up the environment, which we're using Alpine because we're trying to keep this as lightweight as possible. It allocates a Docker engine. Not much to say about that. It grabs the code for us and builds and registers the image. If you want to see more, there we go. If you want to see more about this setup so far, either with Circle CI or our Docker build, you can go into our code repository, and the Circle CI configs are here that just show the process of deployment and using Circle CI for running tests and etc. As well as our Docker file is here as well, if you want to see what that Docker image looks like as we're setting this up. I'll stop at this point and see if there's anything else okay, we're good. So if you have questions, comments, or feedback, you can leave comments on the YouTube video and we will monitor those, or you can, watch our code repository, come see what we're up to, and open an issue if you want to ask something. We'll try to get to it as quickly as we can.